Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so question 4 says a trolley R of mass 15 kg traveling east collides with a stationary trolley S of mass 13.5 kg. And they stick together on impact. After the collision, they continue to move eastwards with a velocity of 4.4 meters per second. Ignore the effect of friction. Then, as we can see here, before the collision, they were moving separately, but then after the collision, they now move together as a unit. So we know this to be case number 2, right? So let's just save that. Then 4.1 says, state the principle of conservation of momentum in weight. We know that's easy peasy. We just say momentum. The principle of conservation of momentum states that in an isolated system, the total linear momentum is conserved. Right. Then 4.2 says calculate the speed of trolley R before the collision. Now that we identify that this is case number 2, that means our equation will have sum of momentum initially is equals to sum of momentum final. Then let's indicate this is 4.2. So we have M1 V1 plus M2 V2. This is M1 plus M2, and then they share the final velocity because remember, after the collision, they now move together as a unit. So that means they share the final velocity, right? Now, what is the mass of trolley R? That's 15. And then we are not given the velocity. And then what is the mass of a trolley S? That's 13.5. But then we are told that it is stationary. So we know stationary means that the velocity is 0 meters per second. So that's 0 here. Then this is 15 plus 13.5. Then our V finally, that's 4.4, right? Then if we are to calculate this, this is 15V, and then punching this into our calculator, we have 125.4, and then just like that, we can divide both sides by 15. 15, then our velocity becomes 8.36 meters per second. Now note we are calculating the speed, so there is no need for us to include the direction there because remember speed is a scalar, it only has magnitude, right? Then let's move to 4.3. It says after the collision, the coupled trolleys, so they're talking about the trolleys that have that are now moving as a unit, right? They remember they stick together, enter into a rough surface. So after the collision, the coupled trolleys enter into a rough surface, which tells us that now there is what? Frictional force, and comes to rest in 3 seconds. Now 4.3 says calculate the magnitude of the frictional force that brought the trolleys to rest. Now before we can answer this question, let's try to draw a free body diagram representing the forces that will be acting on the coupled trolleys. So we know that we have the normal force like that, and then below here we have the gravitational force, and the only horizontal force that will be there will be the frictional force. Remember, we do not have the applied force here because we are not told that the trolleys are being pushed. So we assume that the trolleys are just moving at their own accord. So we only have the frictional force. Now, knowing that the normal force and the gravitational force will just balance each other out, that means the F net will only be comprised of the frictional force, right? So in other words, the F net is the frictional force. So if we are to use the impulse momentum theorem here to calculate, we can then say that whatever magnitude that we are going to find for the net force is the same magnitude for the frictional force, right? So this is F at, and then our delta T, let's just break this one down first. So that's mvf minus vi, then F net delta T, we are told that this is 3 seconds, and then the mass, this is the mass of the coupled trolleys. So we have to add the 15 plus 13.5, that gives us 28.5, right? And then V finally, remember, comes to rest. So this is 0. And then initially, this would be the velocity, 4.4. Then if we are to calculate there, we have now negative 124.4, and then we have to divide by this 3 here. Then our net force is now equals to negative 41.8 newtons, right? But now remember, we said the F net is equals to the frictional force. So therefore, the frictional force is equals to 41.8 newtons, right? So remember, we are just calculating the magnitude, hence we just dealt away with that negative. That negative obviously is telling you that the net force there in terms of the frictional force is acting in the opposite direction of motion. So it is going to the west, right? But then we are not supposed to include the direction because note we are just calculating the magnitude of the frictional force. So, okay, that's how you were supposed to tackle that question there. So if you have enjoyed the lesson and then you have found it helpful, please press the thumbs up button. And then if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.